In this problem, we want to determine the moment of force F about point O, and when we do this, it is helpful to imagine the way the force will create rotations around the axes through point O. That's the one difference between 3 dimensions and 2 dimensions. 2 dimensions, you often think, well, it's a point and things are clockwise or counterclockwise. But in 3 dimensions, it's very different. So you need to imagine, is it going to create a positive rotation about an axis, or will it create a negative rotation about the axis? So point O, back here at the rear of this parallelepiped, and for the force, we note that it is parallel to the x-axis. So F will not create a moment around the x-axis. It could only push in that direction. So we don't have to consider a moment around the I or in the I direction. But it can create moments around the y and the z axes because it does not intersect either of those axes. So for a moment around the y-axis, we note that the force is this distance that I've highlighted, c, above the y-axis. As the force passes through and intersects the YZ plane, that really gives us the closest point to both axes simultaneously. So it's easy to see that C is a perpendicular distance to Y and B is a perpendicular distance to Z. And when we think about the moment here, then as the force comes through and wraps over top of the y-axis, it's going to create a rotation by the right-hand rule that will be positive in the j direction. So the moment around O would be equal. We have the force F times the distance c, and that is in the j. And when it comes through and goes around the z-axis, the tendency for a rotation would be in the negative z direction by the right-hand rule, so minus fb in the k. And that's it as far as the moment is concerned. Now I've done it with the right-hand rule approach. What I want to do now is try a vector approach. And so to that end, let's grab a position vector and we'll sketch 2 of these because it doesn't matter where I go. We can put one position vector from O to this front corner. It just has to get to the line of action, so we could call that R1. And then a second position vector, let's maybe grab a different color here, and we'll draw that to this rear corner of the box, and we can refer to that as R2. And now let's take a moment using those position vectors. So the moment around O is R1 crossed with F. And to get from O to this front corner here, I would go a distance A in the I, plus a distance B in the J, plus a distance C in the K. And that would get me up to there. And I'm going to cross that with my force. My force is easy. It's only in the x direction, so that's F in the I. And then I carry out my cross product. I don't have to worry about I cross I. That has no effect. That would be a 0 term. J cross I would be something, so we're going to write F and then B. And if we think about J crossed into I, we have our little triangle. And if we go this direction, it's a positive, and this direction, it's negative. And so J crossed I will give us a K, and that's a negative. And then we can consider the K cross I term. So we'll just write F times C, and then K cross I, we will be going the other direction around our triangle, and that's a positive J. And you'll notice that this is the exact same expression that we found a minute ago. So there's no difference between the two. Now let's just examine what would happen if we took R2. Moment around O is R2 crossed with F. Alright, and so for this one, R2, we would go a distance B in the J and then C in the K. So it's a little bit different. It's a simpler vector crossing with F in the I. And you'll notice that I really have the exact same thing I just did. So I have the J cross I term, which we've already written as a minus FB in the K. And then I have the K cross I term which I've already written as FC into J. So I would get the exact same thing regardless of which way I did it. So there's three different approaches. If you go with the right-hand rule, then you have to supply the signs based on how the force component will wrap around each axis. And if you go with the vector, then you have to obey the signs that come from the cross products of the unit vectors. So either way, you get the same result.